True Projects. In this video, we are going to explain about the project title Water Quality Prediction using Machine Learning. Before diving into the execution, let me give you an overview of the project. The quality of water directly affects various aspects of life and the environment. For humans, access to clean and safe drinking water is essential for maintaining health and well being. Poor water quality can lead to waterborne diseases and other health issues. Additionally, water quality is vital for sustaining ecosystems, including aquatic habitats and biodiversity. Economic activities such as agriculture, tourism, and industry also rely on adequate water quality for productivity and sustainability. The project aims to create a reliable machine learning system for accurately predicting water quality, enabling proactive water resource management to protect public health, preserve ecosystems, and inform evidence based decision making in water quality management. Traditional methods of assessing water quality often involve collecting water samples and conducting laboratory analysis, which can be time consuming and resource intensive. These methods may not provide real time data or comprehensive spatial coverage, limiting their effectiveness for timely decision making. Additionally, the costs associated with laboratory analysis and field sampling can be prohibitive, especially for large scale monitoring efforts. In response to the limitations of traditional methods, this project utilizes machine learning algorithms such as DB-scan, logistic regression, decision tree, support vector machine SVM, bagging, ADA-boost, voting classifier, KNN, XGBoost, gradient boosting, and random forest to predict water quality. Machine learning algorithms can analyze large data sets quickly and identify complex patterns that may not be apparent through traditional statistical approaches. In this project, we have integrated Flask for building the web application to deploy our project. As an extension, we have used Flask, which provides a user friendly web interface for this project, handling user authentication and data uploads, enhancing accessibility and usability. To implement this project, we need software and hardware requirements. Software requirements of the project are application is Anaconda, primary language is Python, front-end framework is Flask, back-end framework is Jupyter Notebook, databases SQLite 3, front-end technologies used in the project are HTML, CSS, JavaScript, and Bootstrap 4. Hardware requirements of the project are operating system of Windows, processor of Wi-Fi and above, RAM of 8 GB and above, hard disk of 25 GB and above. Algorithms used. These are the algorithms built in the project for predicting water quality. We have built all these algorithms to compare the performance with different evaluation metrics like accuracy, precision, recall, and FN score. And here, the random forest outperformed the other algorithms, and that is the reason we have deployed it in the front end. Now, let us execute the project. To execute this project, first we need to open the code folder, which contains the project source code files. So here, this is the static folder. This folder consists of files related to CSS, JavaScript, and Bootstrap. This is the templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, and more, which represent different pages of the website. This is app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML templates. And here, this is the model file which contains algorithm information which will be loaded into the project code during runtime. This is notebook.ipynb file. This is a Jupyter Notebook file which contains a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for data science. This is signup.db file. This file is the database file used to store user information. And here, this is the data set, water data. Let us open this. In this project, we have utilized the water data set. So here, these are the parameters: station code, locations, state, temperature, DO, pH, conductivity, BOD, nitrate N plus nitrate ON, fecal coliform, total coliform, and here this is the year. So these are the features, parameters based on which we will predict the water quality. So this data is used to train the models. Now close this data. And here we have the test cases which we will use during the execution. So here these are the test cases. Bad quality of water, and these are for good quality of water. Now we need to copy the path of the code folder from the address bar of the file explorer. So here I'm copying the path. Now open the Anaconda prompt. Use the cd command followed by a space and paste the copied path and hit enter. This command is used to change the current directory to the code folder's path. Now compile the app.py file using the command python space app.py and hit enter. This command will execute the Python script and perform a runtime check for any syntax errors or logical issues. After running the app.py file, the Flask framework will host the application locally at the default address, localhost, which is this, and port, which is this. Now copy this local link provided by the Flask framework. I'm copying the link and paste this copied link into any web browser. I usually prefer Google Chrome and hit enter. The homepage of the project is displayed in the browser. This is the front end built using Flask framework. If we are new users, we need to register first. So click on sign up button here. So here we need to enter all these details to register. But I have already registered. So click on sign in. So here we need to enter the username and the password, which are static, and then click on sign in. We need to enter the correct username and the password, and then click on sign in. We have logged in successfully and we are redirected to the prediction page. So here we need to enter these parameters value, and after entering the parameters, the application will predict the quality of water. Before entering the values, let us understand the values. So here the first parameter is temperature. Measurement of the water's warmth, which influences chemical reactions, biological processes, and the solubility of gases like oxygen. Coming to the next one, which is DO, that is dissolved oxygen, indicates the amount of oxygen dissolved in water, crucial for the survival of aquatic organisms and indicative of water quality. pH measures the acidity or alkalinity of water on a scale from 0 to 14, affecting chemical reactions, nutrient availability, and the health of aquatic life. Coming to the next one, which is conductivity, reflects the water's ability to conduct electrical currents due to the presence of dissolved ions, providing insights into the concentration of salts and other dissolved substances. BOD, that is biochemical oxygen demand, measures the amount of oxygen consumed by microorganisms while decomposing organic matter in water, indicating the level of organic pollution and the health of aquatic ecosystems. Nitrate O plus nitrate ON represents the combined levels of nitrate and nitrite nitrogen compounds in water, which can originate from agricultural runoff, wastewater, and other sources and can lead to eutrophication and contamination. Coming to the next parameter, which is fecal coliform. It indicates the presence of fecal bacteria in water, primarily originating from the intestines of warm-blooded animals, serving as indicators of fecal contamination and the potential presence of waterborne pathogens. Total coliform. It represents the total count of coliform bacteria in water, including both fecal and non-fecal types, used as indicators of water quality and contamination. So here we need to enter these values. So we will enter the values from the test cases, which I have already showed you. So here these are the test cases. Let us enter the values from the test cases. So here I am entering these set of parameters. So here the temperature is 26, DO, that is dissolved oxygen, is 4, pH is 7.4, conductivity is 1096, BOD is 26, nitrate ON plus nitrite ON is 3, fecal coliform is 31750, total coliform is 57500. So here we have entered all the values. Now click on submit button. So here we can see we got the result, that is bad quality of water. Based on the entered values, we got the result as bad quality of water. It means that the quality of water is not good, and consuming this bad quality can lead to waterborne diseases. Now let us enter another set of parameters. Let us enter the parameters again from the test cases itself. So here these are the test cases. So let us enter these set of parameters. So here the temperature is 30.6, dissolved oxygen is 6.7, pH is 7.5, conductivity is 203, BOD is 0, nitrate plus nitrite is 0.1, fecal coliform is 11, total fecal coliform is 27. So here I have entered all these values. Now click on submit button. So here we can see the result, that is good quality of water. It means that the water quality is good and this water can be consumed by humans. Now let us enter another set of parameters. Let us enter another set of parameters from the test cases itself. So here let us enter the set of parameters. So here the temperature is 19.1, DO, that is dissolved oxygen, is 4.7, pH is 7.2, conductivity is 202, BOD is 13.6, nitrate plus nitrite is 15, fecal coliform is 13444, total coliform is 20056. So here I have entered all the values. Now click on submit button. So here we can see the result, bad quality of water. It means that the water quality is bad, which can lead to waterborne diseases. So in this way, just by entering the parameters, we can predict the quality of water as good or bad. Now click on sign out link here. So, the project successfully developed machine learning based predictive models for water quality assessment, demonstrating their effectiveness in improving prediction efficiency and accuracy. The conclusions offer promising prospects for environmental agencies and policymakers, facilitating better informed decision making. Future research may focus on refining existing models, exploring additional algorithms, and integrating more data sources to enhance prediction accuracy further.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.